Okay guys, I'm going to help you with tonight's homework for lesson 6 from module 4. And as you can see, it says that you're going to need a protractor to measure these angles. I sent you guys home with those circular protractors. You can just check your work here. It took me so long to record this because I had to lay an actual protractor on the iPad to draw this, so forgive it, you can't really see. What I'm going to do here is I'm going to extend this line so it's easier for me to measure, and I know you can't see it, but I'm placing the protractor on the vertex, lining it up with the 0, and then seeing where the line touches, and it touches at 65 degrees. And I'm going to do the same thing with B, C, and D. When you use your protractor, you need to make sure that the center lines up with the vertex, that one of your rays is lined up with the 0 on the protractor, and the other one is what you use to see the measure. So on B, I'm going to see, it's taking me a second, just hold on. It's about 77 degrees. Here on part C, I'm going to extend the line again to make it easier to see with my protractor. I'm going to line up the short ray with the 0 on the protractor and see where that touches. And obviously this is an acute angle, so if I get anything other than an acute number, like less than 90 degrees, it's wrong. So here I got 32 degrees approximately. It's okay if you're off by 1 or 2. Same thing on D. Gonna line it up. And I get about 60 degrees is where that's pointing to. Okay, on the next section, I'm going to start with E. And again, I'm going to extend that line over here. Hold on, it's taking me just a second. And I'm going to line that up to measure it. Setting the protractor on top of the screen, just like we practiced in class. And when I line that up, it looks like it's, well, obviously this angle is obtuse, so, and I got 105 degrees, so that seems about correct. It's bigger than a right angle, so I should get a little bit more than 90 degrees. Here, this angle is obtuse as well, so I should probably get something bigger than 90 degrees. And when I measure it, give me just a second to line it up. Oops. Okay, having some technical difficulties. Hold on, it's hard to measure on the glass screen. Okay, here we go. It looks like it's about 150 degrees. Which makes sense, because it's pretty close to a straight line, which would be 180. Same thing here on G. And, hold on. Okay, back up, having some technical difficulties. On G, when I line up the protractor, it looks like, obviously this is obtuse, so it's going to be bigger than 90, and when I line it up, I get, looks like it's going to be about 130 degrees. Now it's okay if you're a degree or 2 off. Just as long as you're in the same ballpark. I would say more than 5 degrees off, and you probably need to remeasure if yours don't match mine. This one is obviously acute. It is smaller than a 90-degree angle, so I should get a measure that's smaller than 90. And when I measured, I got 65 degrees. I and J, well, I is obviously acute, so it should be less than 90. And when I measure, I get, looks like it's about 45 degrees. And when I measured J, that looks just a tiny bit bigger than a right angle, to be honest. I'm going to have to turn my protractor a weird way to measure this, so just give me a second. And when I measure it, it looks like I get about 120 degrees, which makes sense because it's obtuse. Alright, number 2. It's a little bit confusing, but it says using the red and green circle cutouts from today's lesson. So we used not the same color, but we had some cutouts. Explain to someone at home how the cutouts can be used to show the angle measures of the same length, though the circles are different sizes. So basically what I'm going to write here is that even though this one circle is a lot smaller than the other, and the arc, like the outside of the circle, is bigger on the red one, they both still make right angles. No matter how long the lines are on the angle, it doesn't change the measure of it. So I'm going to say they can be used to measure angles the same way because the arc, or the size of the arc, doesn't change the size of the angle or the angle itself. Okay, last one, number 3. Use a protractor to measure each angle. Extend the length of the segments as needed, just like I've been doing this whole time. When you extend the segments, does the angle measure stay the same? We just talked about that. The angle measure is going to stay the same even when I extend the segments. It doesn't affect the actual angle itself. So here I'm going to extend the line. This almost looks like a straight line, so it should be pretty close to 180. And I got 170, and on B, this is a straight line, so that should just be 180 degrees.